Today I'm with a different problem, right? I'm with a different function to sketch. All right. So let's see how to sketch this rational function. So we can see here it's a rational function. A rational function will have two parts, numerator and the denominator. Always remember, in a rational function or a fraction, the denominator cannot be equal to 0. Here, x squared plus 1 cannot be equal to 0. Okay. So from this statement, we can find the vertical asymptotes. Right? But here, fortunately, x squared plus 1 is not equal to 0. Cannot be equal to 0 because this function is always positive. So since this one is always positive, this one cannot be equal to 0. Right? So here, you can't find any vertical asymptotes. Alright? Okay. So next, as usual, right, we can differentiate this. So if dash x. Alright. Okay. So how can we differentiate this one? And I hope that you have known how to differentiate this. Okay. So if you're not familiar with this, what do you call that? U over V differentiation, you better go back to your basic differentiation and come back to this problem. Okay. So how can we differentiate? There's a function here in the numerator and there's another function here in the denominator. So you have to start off with the denominator. First of all, you have to write x squared plus 1, right? Which is in the denominator, into the differentiation of x. The differentiation of x is equal to 1 minus, right? Now you have to do the same process the other way around, right? You have to write whatever in the numerator, x into the differentiation of the denominator, right? So you have to differentiate this expression x squared plus 1. If you differentiate it, it's going to be 2x plus 0, 2x. Divided by square of the denominator, x squared plus 1 whole thing square. Alright? So if you simplify this, f dash x, right? Simplify this and factorize this. So x squared plus 1, x squared plus 1 minus, if you multiply this together, 2x squared divided by x squared plus 1 whole thing square. So f dash x is equal to 1 minus x squared divided by x squared plus 1 whole thing square. Right? So if you do it further, f dash x, simplify this one and factorize it. So it's going to be the factorization of this one. Right? You have to factorize the numerator part. So 1 minus x squared can be written as 1 minus x into 1 plus x. Okay, we have factorized it. Divided by x squared plus 1 whole thing square. So this is the differentiation. So from this one, from this first derivative of this function, we can find the turning point. So how can you find it? So in order to find the turning point, you have to equate f dash x to 0. Okay. So 1 minus x into 1 plus x divided by x squared plus 1 whole thing square, that is equal to 0. So if this expression has to be equal to 0, right? Then, so you can just multiply this one. Right? Okay. So 1 minus x, right, into 1 plus x has to be equal to 0. So the solutions are x, you can say that 1 minus x is equal to 0, 1 minus x is equal to 0, or 1 plus x is equal to 0. Right? So x is going to be equal to 1, or x is going to be equal to minus 1. So these are the x coordinates of the turning points. Right? One of the turning points will have 1 as the x coordinate and the other will have minus 1 as the x coordinate. Okay, so from this one you can find the corresponding y coordinates of the turning points. Now we have to find the corresponding y coordinate of these two points. So first, when x is equal to 1, what is the corresponding y coordinate? So when x is equal to 1, this is the function that we are going to sketch, right? So when x is equal to 1, you have to find the y coordinate. So here you have to substitute 1. If you substitute 1, 1 over 1 squared plus 1, yes, and that's equal to half. So one of the turning points is 1 comma half. When x is equal to minus 1, when x is equal to negative 1, so what about y? Y is equal to minus 1 over minus 1 square plus 1, so that is quite obvious, minus half. So the other turning point is minus 1 comma minus half. So these are the two turning points. But still we don't know what kind of turning points these are. Are there maximum points or minimum points? We have to verify that. So you already know how to verify that. Alright? Okay, fine. So these are the turning points that we found so far. And this is the first derivative. Right? So we have to check what kind of turning points these are. So you have to draw a number line for x. Always remember you have to denote the x coordinates, only the x coordinates of the turning points. Right? One is minus 1 and other is positive 1. So we know that these two values actually divide this number line into three different parts. We can call this part as x is smaller than minus 1. Here, x is in between minus 1 and positive 1. Here, x is greater than 1. So you have to draw the table. The first region. So this region is denoted as x is more than minus 1. X is in between minus 1 and 1. And this region is x is greater than 1. Right? So you have to complete the table. In this table, the second row should be the first derivative of x of fx. So third row has to be fx. So the next step what you have to do is you have to find the sign of f dash x. So you have to show, so you have to find the sign. You have to show whether it is plus or minus in these sections. Alright? Okay. So when x is smaller than minus 1, what happens to f dash x? In other words, the rate of change of fx. Right? So you have to use this equation that you got. Right? The first derivative of fx. Right? When x is smaller than minus 1, imagine a number which is smaller than minus 1. Let's say 2. Sorry, let's say minus 2. When x is equal to minus 2, what happens to f dash minus 2? Is it positive or negative? That's what you have found. Right? So 1 plus 2, because 1 minus minus 2, so it's going to be 1 plus 2. Right? 1 minus 2 here. I'm substituting here. Right? Over 1 plus x squared over x squared square. So 1 plus minus 2 square, that's going to be equal to 4, right? To the power 2. Right? So definitely this one is going to be positive. Anyway, it's going to, the denominator part is going to be positive. Right? So only the numerator part is going to decide the sign of f dash x. So 1 plus 2, that's going to be equal to 3. Yes, 1 minus 2, that's going to be equal to minus 1. So this is definitely negative. So in this region, f dash x is going to be negative. Which means in this region, when x is more than minus 1, fx actually decreases with x. Right? Okay. The next thing I have to check. When x is in between minus 1 and 1. Okay. So you can consider easier number, right? Just imagine a number which is in between minus 1 and 1, right? 0, right? It's a perfect candidate, right? So you substitute here. Substitute 0 here. 1 minus 0, right? So f dash 0. Again, I'm telling you, you don't have to do it in your paper or book, whatever, right? You can just do it in your mind, right? If you're familiar with these things, you can just do this part in your mind, right? So f dash 0. If you substitute 0 here, it is 1 minus 0, right? 1. 1 plus 0, 1. Divided by, if you substitute 0 here, 1 plus 0, right? 1 square, 1. That is equal to 1, which is positive, right? This is positive. Alright? Okay? So here in this region, where when x is in between minus 1 and 1, right? Fx is going to increase with x, right? If it's increasing, you have to draw the line like this, okay? If it's decreasing, you have to draw it like this. So when x greater than 1, right? Imagine a number which is greater than 1. Okay, let's say 5, positive 5, right? Substitute 5 here. 1 minus 5, that's going to be negative, right? Negative. 1 plus 5, that is positive, right? If you substitute 5 here, right? Definitely, whatever you substitute for x here, that's going to be positive. No matter what. Okay? It's positive. So negative into positive, negative, over positive, that's going to be negative. So when x is greater than 1, right? f dash is negative, which means in this region fx or y will decrease with x. Alright. So this one will give you the basic shape of the graph. So you can see here when x is equal to minus 1, right, the graph will have a minimum point. When x is equal to 1, the graph will have a maximum point. So you're gonna get a graph like this, right? Alright, when x increases, it'll go down, right? It'll have a minimum point, it'll come up, it'll have a maximum point, and it'll go down. Are you clear, guys? Right? Hope you can understand. Alright, viewers, so far we have found that 1 comma half is maximum point and 1 minus 1 comma minus half is a minimum point. Right? So we have found what kind of turning points these are. The next thing what you have to do is, yes, you have guessed it, most of you would have guessed it if you have gone through my previous videos, right? We have to see what happens to y over fx, this function, what happens to this function when x tends to positive infinity or negative infinity, right? If you want, you can just check them separately, or else we can, in certain instances, you don't have to find them separately, right? You can just uh, do it generally. Okay, right. What happens when x is plus or minus infinity? So we have to find the y value. What happens to y? Or fx, the function. Limit x tends to positive or negative infinity, right? The function is x over x squared plus 1. Alright, okay. I hope you have basic knowledge in limits. Alright, okay. So, how to find limits? Here you cannot substitute infinities straight away. Okay. So, when you're substituting infinities to rational function, what you have to do here is, right, just see what you have in the denominator. Yes, you have a polynomial. Fine. In that this polynomial is a second order polynomial. So if it's a second order polynomial, you have to divide both the numerator and the denominator by x squared. Right? If the numerator is a third order polynomial, you have to divide the numerator and the denominator by third order by x cubed. Right? Okay. So here you have to divide both the numerator and the denominator by x squared. If you divide x by x squared, right? If you divide x by x squared, it's going to be 1 over x. Alright? If you divide this x squared by x squared again, that's going to be equal to 1 plus 1 over x squared. Now you substitute infinity. Right? If you substitute infinity, it can be positive infinity or negative infinity. Right? It will be 0. Whether it's positive infinity or negative infinity, x squared is x, because when x is infinity, x squared is definitely going to be infinity. Right? Okay? Square of a very big number, it's going to be a huge number. So this is 0. So if you continuously do it, y is equal to 0 over, right, 1 plus 0. So y is equal to 0. When x tends to infinity. It can be either negative infinity or positive infinity. Both instances, y is getting an infinite number. And that can happen. The previous example, the previous functions, we saw that when x tends to positive or negative infinities, right? Okay, the function will either go to positive infinity or either go to negative infinity. But this one's a bit different, right? So this kind of situation you encounter when you are drawing rational functions. Okay, right? Here, when x tends to positive or negative infinity, a strange thing is happening. Y is obtaining a finite number. Right? Okay, so in these situations, right, when you substitute an infinite value for x and you in return when you get a finite value for y, right? Okay, we call it the horizontal asymptote. So y is equal to 0 is a horizontal asymptote. Horizontal asymptote. Okay, there are actually vertical asymptotes as well, right? Okay, I will teach about vertical asymptotes later, right? Because this problem doesn't have vertical asymptotes, right? Y is equal to 0 is a horizontal asymptote. Always remember. Alright, guys, now we can sketch the graph. This is the x-axis and this is the y-axis. This is the origin. Okay. So what are the turning points? So we found the turning points to be one is 1 comma half. Yes, one is 1 comma half, and that's the maximum point, right? And the other one is minus 1 comma half. Minus 1 comma minus half. I'm sorry. This is 1 comma half, right? Okay, fine. So that's an asymptote, right? Where what is an asymptote? Y is equal to 0 is a horizontal asymptote. Y is equal to 0 is a horizontal. What is y is equal to 0? Y is equal to 0 means x-axis. X-axis is a horizontal asymptote. So you have to draw a dot dot line like this. Okay, this is a horizontal asymptote. So here you have a minimum point. Okay, that's fine. Here you have a maximum point. Okay, fine. So the graph will go on like this. Right, okay. So what is the meaning of asymptote? So what is the meaning of horizontal asymptote? So what happens is when x goes to positive infinity, right? Be clear. When x goes towards the positive infinity, when x increases, right? What happens is after 1, actually the graph decreases and reaches this asymptote. It does not touch, right? Always remember, it cannot touch the asymptote, but it actually reaches the asymptote, right? It will go on like this. Okay, it will touch the asymptote in the infinity, right? It means it never touches the horizontal asymptote, right? Okay. Here what happens is when x passes this minus one mark, right? When x decreases, right, the graph actually reaches the asymptote, right? The graph will go on like this. Okay, fine, right? So here, so you have to connect these two. This graph actually goes through this origin, right? You can show how it goes through this origin. What you have to do is you have to make when x is equal to 0, right? When you substitute 0 here, when x is equal to 0, what happens to y? What happens to the function fx, right? Substitute 0 here, 0 over 0 squared plus 1, 0. So the graph goes through the origin. Graph goes through the origin. So this is the graph, right? Hope you can understand this. Alright. So there's one more thing you have to discuss about, right? In exam papers and in exams, they ask you to discuss about the concavity of this graph. Right? They'll ask you to find the to discuss about the concavity of this graph. So for the time being, I recommend you to pause the video and just go through the things that I went through and try to draw the graph, right? Okay. After drawing the graph, you can talk about the concavity of this graph or how to find the inflection points in this graph. Okay guys, in order to find the inflection points of this graph, right, I already taught you that you have to find the second derivative of this function. For the second derivative, you have to differentiate the first derivative again. Okay, so here f dash x, for my convenience, actually I just keep this function like this. 1 minus x squared, if you multiply these two, it will be 1 minus x squared divided by 1 plus x squared whole thing squared. Right? So if you differentiate this one, right, it's going to be, so again it is a u over v function, right? So you have to differentiate like you differentiate any other rational functions, right? So if you differentiate this one, 1 plus x squared whole thing squared into differentiation of this function, right? That is minus 2x, okay? Minus 1 minus x square into the differentiation of this one. It's going to be 2 times 1 plus x square, right, into differentiation of this one is 2x. Okay, can you understand this one, right? Divided by 1 plus x square, right? Square of this 1 plus x square whole thing square. So that is to the power. Okay, so if you simplify this one, it is going to be, you can take negative 2x, there's a 2x here, right? 1 plus x squared, both things squared, 1 plus x squared. So you can take negative 2x into 1 plus x squared as a common factor. If you do so, here you'll be having 1 plus x squared, right? Plus 2 times 1 minus x squared. Okay. So simplify it as much as you can. Right. Here you have 1 plus x squared. Here you have 1 plus x squared whole to the power 4. So you can simplify, right? So that is equal to minus 2x If you simplify this one, you'll be getting 3 minus x square divided by 1 plus x square whole thing cube. So f double dash x is equal to, I'm doing the remaining part here, right? Okay? Right. F double dash x. There's a negative here. What I'm going to do here is I'm going to multiply this 3 minus x squared by this negative sign. Okay? Negative number. So it's going to be 2x. X squared minus 3 divided by x squared plus 1 whole thing cube. This is the second derivative of this function. Okay? Second derivative of f. So in order to find the inflection points, I already told you what you have to do is you have to equate this second derivative to 0. Right? Then you can f dash x. Right? For inflection points. Right? You have to equate f double dash x to 0. Right? So we have already found f double dash x. So if you equate this to 0, 2x x squared minus 3 divided by x squared plus 1 whole thing cube, that's going to be equal to 0. Okay. You can just cross multiply, right? You can just divide the 2 with 0. So x into x squared minus 3, that's going to be equal to 0, which means x is equal to 0 or x squared minus 3 is equal to 0. X is equal to 0 or x is equal to, right, x squared is equal to 3. So the solution is going to be x is equal to 0 or x is equal to plus or minus root 3. Right? So you have to find the corresponding uh, turning points. Right? Okay. So not turning points, corresponding coordinates. I'm sorry. So when x is equal to 0, right, y is also equal to 0. Right? Just substitute here. When x is root 3, positive root 3, right? Okay. Substitute root 3 here. So it's going to be, yeah, root 3 square, right? 3 plus 1, root 3 by 4. Minus root 3. If you substitute minus root 3 here, you'll be getting minus root 3 by 4. Okay. So these are the turning points. Sorry, these are the inflection points. So what are the inflection points? The origin, root 3 comma root 3 by 4, negative root 3 comma negative root 3 by 4. These are the inflection points. Okay. So you Alright guys, these are the inflection points, and using these inflection points, you have to discuss the concavity of the graph. Right? So in most exam papers, you are asked to describe the concavity of the graph, right? Using the inflection point, but that's very simple, right? Okay. So you have to consider the x coordinates of the inflection points, and you have to consider a number line of x, right? In the number line, okay, you have to denote the x coordinates of the inflection point. So what are they? Negative root 3, 0, positive root 3. Right? So these 3 points actually dividing this number line into 4 different sections, right? So x is smaller than negative root 3, right? Here x is in between my negative root 3 to 0, 0 to root 3, and greater than root 3. So just draw a table. Okay, so x is smaller than minus root 3, right? X is in between minus root 3 and 0. X is in between 0 and root 3. X is greater than root 3. Consider these parts. Okay, so these are the regions where the concavity is going to change. Okay, fine. So you have to check the sign of f double dash x. Okay, whether f double dash x, which is the second derivative of this function, is positive or negative. Always remember guys that if when in a region f double dash x is positive, right, it is concaving up. Concave up. Alright. Whenever the second derivative of fx is less than 0, is negative, it is concaving down. It's concaving down. Concaving down, concave down. Okay. Understood? Right. So you have to check the signs. Right. When x is smaller than negative root 3, right? Just imagine a number which is smaller than negative root 3. Let's say negative 5. Substitute it here. If you substitute negative 5 here, negative 5 into 2, yes, negative 10, negative. Here this is going to be positive because negative 5 square, that's 25. 25 minus 3, that is positive. Right? Substitute negative 5 here, right? Negative 5, 25 plus 1, that's positive, right? Cube, that's going to be positive. Okay. So what can you say about the sign? Negative into positive, negative, negative over positive, negative. So here this region is negative. So it's going to concave down. It's concave down. Concave down. Alright? Okay. And when x is in between minus root 3 and 0, you can take easiest number minus 1, negative 1. Right? If you consider negative 1, take negative 1 and substitute here, negative 1. Right? This part is going to be negative. Okay, fine. Negative 1 here, it's negative because negative 1 square 1, 1 minus 3 negative. Negative 1 here, it's positive. Right? Positive. When the second derivative is positive, right, the graph is going to concave up. Okay, always remember that. When positive, concave up, negative, concave down, right? So when x is in between 0 to root 3, right? Okay, take a number within the 0 to root 3. Okay, let's say 1. Okay, so we substitute 1 here. Okay, I'm going to substitute 1 here. It's going to be 2 into 1, positive. I'm substituting 1 here, 1 minus 3, negative, right? 1 here, positive. So what about the sign? Positive into negative, 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 it's negative. Concave down. Hope you can understand this, okay? Consider a number greater than 3, so greater than root 3. Let's say 5, substitute 5 here, definitely it's going to be positive. Just substitute and see. If it's positive, it's going to concave up. It's going to concave up. Okay? Right? Here you don't have to draw it. Okay, even if you can write fx, it's fine. So fx is concaving down, concaving up, concaving down, concaving up. Okay. Now we'll go back to the graph that we drew previously. Okay guys, this is the graph we got, right? So where are the concave points? So one of the concave points is origin that we found, 0, 0. One of them is root 3 by 4. And one of the other concave point is negative root 3, comma, minus root 3 by 4. Okay, right. So you can see, yeah, you can see right here. When x is more than negative 3, it's concave down. Yes, it's concave down because this part is part of this graph. It's concave down. It's concave down. It's concave down. Right. When the graph is in between negative root 3 and 0, right, it is concaving up definitely. This is concave up. I already told you, right? It's concave. Always remember, right? This part is concave up. Concave down. I'm sorry, concave down. Right? This part is concave up. Always remember, right? So it's concaving up. Okay, fine. When x is in between negative root 3 and 0, it's concaving up, right? When x is in between 0 to root 3, yes, it is concaving down. But here somewhere the concavity is changing, right? When x is greater than root 3, it's changing to concave up. It's concaving up. Right? It's concaving down and it's concaving up. So here somewhere the concavity is changing. Here somewhere the concavity is changing in the origin. Right? Here also the concavity is changing. Alright guys? So I hope you can understand this. Alright? It's enough if you can draw up to. It's a great thing if you can draw up to. If you can draw the graph, right? It's better, right? It's better if you can know how to explain the concavity of the function that you have drawn. Hope you can understand the things that I have taught you, right? Please, it's better if you can do it in your own. So thank you for watching my videos. So hope you can like and subscribe my channel. Thank you very much.